Today I'm going to show you Quartic AI's reliability application, which uses the risk-based reliability-centered maintenance, or RCM, approach. We have worked closely with industry experts in the Reliability and Maintainability Center at the University of Tennessee to implement a digital version of the industry standard RCM approach. In doing so, we want to focus on the assets that are contributing the most to our risk, and following the 80-20 rule, typically 80% of the risk will come from only 20% of our assets, so that's where we want to focus our efforts. For quantifying risk, we use a risk priority number, which has three components: severity, which primarily comes from a failure modes and effects analysis, where possible failure modes are identified for each piece of equipment, and how critical each of those failure modes is also determined. Occurrence, which is what we'll be using the Quartic platform and reliability application to track, is how frequently each one of those failure modes triggers. And we do this using different rules and agents to see how my asset accumulates risk over time. And finally, we have detectability, which is what we're using machine learning to improve. We want to detect failure modes that may be missed or caught too late using simple condition sensors like vibration, and we want to detect these anomalies earlier and predict potential failures before they happen so we can mitigate these issues. In terms of a workflow, first we need to identify which assets are my critical ones that I need to be monitoring, and perform a failure modes and effects analysis, or FMEA, on those assets to determine the failure modes and the severities of those failure modes. Based on that, I'll choose which failure modes we want to or need to monitor, and how we're going to detect them within our reliability application. So we'll leverage our OT data, sensor data, CBM, vibration, MES, etc., to implement agents to identify when failure modes occur, or are going to occur. So depending on the type of failure, we may use baselining and anomaly detection, or we may use machine learning for predictive failure mode detection, or more of a condition-based approach, comparing, say, vibration to a threshold. We can also use a combination of these methods. So in the case of vibration, maybe there's a threshold, but also a specific vibration pattern we can detect via anomaly detection for a specific failure mode like pump cavitation. So we deploy these rules and agents to detect the failure modes. From FMEA, we have the severity, and then our application is tracking the frequency. So from this, we get our asset risk scores, as well as abnormal operation time, which is AOT. This then gives us actionable information about not only what assets need attention, but what type of failures they experience, so we can notify someone, take action, create work orders in a CMMS system, whatever we need to do. So this is the RCM workflow. And again, it's not a workflow that Quartic came up with, but an industry gold standard of reliability-centered maintenance that we created a digital implementation of using machine learning. So what we're really looking at understanding is the degradation of your assets over time and the risk they accumulate so you can plan some informed action. And that's really what you and reliability leaders want at the end of the day, to make maintenance decisions and take maintenance actions based on your asset health and quantified risk. So that should give you some solid background on RCM. Now I'm going to navigate into the Quartic platform and show you how the implementation of this RCM workflow from an end user perspective is done using the Quartic reliability application. So I start with an overview of my assets along with a few key metrics: the abnormal operation time, which accumulates to the potential degradation of my asset; my current risk, which is cumulative across all failure mechanisms that I've identified and built machine learning models to detect; and then, based on the failure mechanisms that trigger, I have actions that I should take to ensure the functionality of my assets. So this gives reliability leaders an overview of how RCM is being applied at their facility. From here, we want to take a closer look at one of my troublesome assets. So I'll go into this hydraulic system asset to take a deeper look. On this more detailed screen, the two main things that stand out are these charts: my loss of function risk index and the abnormal operation time per hour. So we can see how our abnormal operation time and risk change and accumulate, but more importantly, how this is changing over time. So I also have the rate of change of abnormal hours, which lets me understand how fast my asset is potentially degrading and the acceleration of degradation. which, if you think about a potential failure curve, this is how far to the right on that curve I am, and how quickly I'm approaching an asset failure that I need to take action to avoid. So I have instances of abnormal operation here. Well, why did this trigger? What failure mechanism is active? I have different rules or agents running to monitor this asset, so I can jump into those to see which one's triggered, causing the abnormal operation time. I have prime agents, which are simpler rule-based ones like violating a pressure differential across a filter. I can also have predictive agents that use a predictive machine learning model, so in this case looking at a predictive cooling efficiency. And finally, I can have anomaly detection agents that compare my current operation to a baseline. And if you remember the RCM workflow, first we identify the failure mechanism to detect this internal pump leakage. I've built a machine learning model for detectability and deployed that model as a live agent to track occurrences for this failure mechanism. So as I look at each failure mechanism, I can see a breakdown of each occurrence that occurs and the status that triggered it. But why did this happen? Yes, I had an anomaly and I could see a higher anomaly score, but what did the machine learning model actually pick up? What were the underlying factors contributing to this anomaly score? So this last occurrence was on December 7th around 6 a.m. And if I go into my model view for internal pump leakage, I'll be able to take a closer look at what actually triggered this. So I'll zoom in on the time range where this anomaly triggered, and I can actually see the spikes in the anomaly score. So what's happening is I baselined my pump during normal operation, and I'm now comparing real-time data against that baseline and getting a corresponding score where 0 is normal behavior matching the baseline, and 100 is completely abnormal behavior off that baseline. So I can see where my anomaly score spiked, this anomalous behavior, and I can see these influencing factors, a pressure, a flow rate. These are the variables that the ML model detected abnormal behavior on relative to the baseline. So this is what's causing an anomaly to trigger, but when it triggers, what action do I need to take, if any? That's where my action log comes in. So anytime one of these failure modes triggers, I can see what specific action I need to take, and it's going to be directed at specific users. So it's telling them what to do. They can add in comments, acknowledge this, so this becomes a tracking system for not only events that occurred, the abnormal operation, but what was done about them and who was responsible. Now this is looking at a single occurrence, but I could also set up an agent to look at a collection of occurrences, which is moving towards that rate of change I want to look at. So I set up an alert where if the rate of change of abnormal operation time is increasing, meaning the amount of time I'm spending in failure modes is accelerating, then I want to be notified. So I'm triggering off this AOT rate of change. I can see what asset it occurred on and when it happened. So from this notification, I can come back into my action log and see what contributed to that high rate of AOT change. And here we can see we have a high occurrence rate for internal pump leakage, which is also linked into our abnormal operation time. So this failure mode is a major contributor to my overall increased rate of abnormal operation time. And because this is accelerating, our risk of failure is also accelerating. So this is now more urgent, and we want to take an action on it. So we're asking the operator to investigate and open a request in the CMMS for physical inspection of the pump. And this work order creation is something that we can automate as well if desired. Now we could go one step deeper into actually building the machine learning models, but we won't go into that today. But this should give you a pretty good understanding of how to go through this digital RCM workflow. Beginning with our asset and data, we built our machine learning models and rules on top of that data to monitor the important failure modes. We can then track those failure modes within the reliability application and see how those modes contribute to my overall abnormal operation time and ultimately asset risk. So I have an understanding of where my risk is and what actions I need to take to ensure the health and functionality of my asset and my overall process. So with that, I'd like to thank you for watching today. And if you have any questions, please reach out to us here at Quartic AI.